Before humans built cities, kingdoms, or armies, they built weapons, and the first ones were not forged. More than 2 million years ago, early humans discovered that a broken stone could produce something extraordinarily useful: a sharp edge. What began as a tool for cutting meat, breaking bones, and processing plants eventually became something else: a weapon. Stone could cut, wood could strike, and when humans learned to combine them, warfare began to change. A wooden shaft hardened in fire could become a spear. Attach a sharpened stone point to that shaft using plant fibers, animal sinew, or natural adhesives, and suddenly a hunter no longer needed to stand directly beside a dangerous animal or an enemy. This was one of humanity's earliest technological advantages: distance. Eventually came the bow, a flexible piece of wood, a tensioned string, and a lightweight projectile allowed humans to deliver lethal force from far beyond the reach of a spear. But for thousands of years, the material itself remained largely unchanged: stone. Then humans discovered something hidden beneath the ground: metal. Sometime during the Neolithic and Chalcolithic periods, communities in parts of the Near East began working with naturally occurring copper. At first, copper could be hammered into simple shapes, but craftsmen eventually discovered something far more important: heat could transform metal. When certain rocks containing copper ore were heated intensely enough, metallic copper could be separated from the ore. This was smelting, and it fundamentally changed human civilization. But early copper had a problem. It was relatively soft. A copper blade could be sharpened, but under heavy impact it could bend or lose its edge. Then ancient metalworkers made one of the most important discoveries in technological history. Mix copper with another metal, most famously tin, and the resulting alloy becomes considerably harder: bronze. By roughly the 3rd millennium BC, bronze weapons were transforming warfare across Mesopotamia, Egypt, Anatolia, and the Eastern Mediterranean. Making them required an increasingly sophisticated process. Copper and tin were obtained, transported, and heated inside furnaces. Craftsmen needed temperatures exceeding 1,000 degrees Celsius. Air supplied through blowpipes and later bellows intensified the fire. Once molten, the metals could be combined and poured into carefully prepared molds. After cooling, the weapon was removed, shaped, polished, and sharpened. For the first time, weapons could be manufactured with a level of consistency that stone could never provide. Bronze swords appeared. Spearheads became stronger. Axes became deadlier. Armor became increasingly sophisticated. But metallurgy changed more than the weapon. It changed civilization itself. Copper and tin were not available everywhere. A kingdom that wanted bronze needed mines. If it did not possess those mines, it needed trade. If trade failed, it needed conquest. Suddenly, the materials required to manufacture weapons became strategically important resources. Ancient armies were no longer dependent only on courageous warriors. They depended on miners, merchants, metallurgists, furnaces, workshops, transportation networks, and skilled craftsmen. War was becoming an industry. And then came iron. Humans had known about iron for centuries, sometimes through extraordinarily rare pieces of meteoritic iron. But extracting useful iron from terrestrial ore was much more difficult than working copper. Iron required different metallurgical techniques and extremely controlled furnaces. Instead of simply pouring fully molten iron into a sword mold, early ironworkers commonly produced a porous mass known as a bloom. The bloom contained iron mixed with slag and impurities. A smith then had to repeatedly heat it, hammer it, fold or work it, and hammer it again. Every strike helped force impurities from the metal and consolidate the iron. This was physically demanding, highly skilled work, and the person performing it, the blacksmith, became one of the most important craftsmen in ancient society. The furnace produced the metal, but the hammer created the weapon. By controlling heat and carbon, smiths eventually learned to produce forms of steel, iron containing enough carbon to become significantly harder when properly treated. This opened another technological frontier. A weapon could now possess competing qualities, a hard edge capable of staying sharp, and a tougher body capable of surviving impact. Smiths learned through generations of experimentation that temperature mattered enormously. Heat meddled too little and it could not be shaped effectively. Heat it incorrectly and its properties could suffer. Cooling techniques could alter hardness. Reheating and tempering could reduce brittleness. Long before anyone understood metallurgy at the atomic level, blacksmiths were manipulating the microscopic structure of metal through experience. They didn't need to understand the chemistry, they could see the results. A sword either survived battle or it didn't. By the first millennium BC, iron weapons were spreading across the ancient world. The Neo-Assyrian Empire became famous for combining military organization with extensive use of iron equipment. Its armies deployed infantry, cavalry, chariots, archers, engineers, siege equipment, and sophisticated logistics on an enormous scale. Weapons were no longer isolated objects created for individual warriors. They were components of military systems. The Greeks refined another system around the hoplite. The spear became the primary weapon, while the short sword served as a secondary weapon. Bronze helmets, cuirasses, greaves, and the large round aspis shield transformed individual soldiers into parts of a tightly organized phalanx. Then Macedonia changed the equation again. Philip II equipped his infantry with the sarissa, an extraordinarily long pike requiring coordinated formations. His son, Alexander the Great, combined the Macedonian phalanx with cavalry, missile troops, and other specialized forces to conquer territory stretching from Greece to Egypt and deep into Asia. Rome took standardization even further. Roman military power was not based on possessing some magical sword unavailable to everyone else. Its advantage came from organization. Weapons, armor, engineering, logistics, training, and manufacturing worked together. Roman soldiers carried equipment including the gladius, pilum, shields, helmets, and body armor, while enormous logistical networks supplied armies operating hundreds or thousands of kilometers from Italy. By this point, the weapon had become inseparable from the state capable of producing it, but metallurgy continued evolving. Across Europe, the Middle East, India, China, and Central Asia, smiths developed increasingly sophisticated methods of manipulating iron and steel. Indian crucible steels, often associated with what later became known as Wootz steel, became famous for exceptional qualities and contributed to traditions connected with so-called Damascus steel. In East Asia, metallurgists developed their own sophisticated iron and steel industries. In medieval Europe, improvements in furnaces and metalworking supported increasingly specialized swords, axes, polearms, crossbows, helmets, mail, and eventually plate armor. The competition was constant. Better armor encouraged better weapons. Better weapons encouraged stronger armor. Then gunpowder disrupted the entire system. A substance developed in China eventually transformed warfare across Eurasia. Early gunpowder weapons were crude, but cannons became stronger, firearms became more reliable, and the purpose of the metalworker began changing again. For thousands of years, weapon makers had concentrated on producing stronger edges and sharper points. Now they needed barrels capable of containing explosions. Metallurgy entered a new age of precision. By the Industrial Revolution, weapons manufacturing was leaving the traditional workshop. Machines could produce standardized components. Factories could manufacture thousands of nearly identical weapons. Steam power improved steelmaking, precision machining, and interchangeable parts transformed military production. A weapon was no longer necessarily the creation of one blacksmith. It became the product of an industrial system, and that transformation eventually produced repeating rifles, machine guns, enormous artillery pieces, armored vehicles, aircraft, and the mechanized arsenals of the 20th century. The materials changed. Stone became copper, copper became bronze. Bronze gave way to iron. Iron evolved into increasingly sophisticated steels and modern alloys. But the fundamental reason behind this progression remained remarkably consistent. Humans faced a problem and searched for a material, shape, or process that provided an advantage. A sharper edge, a longer reach, a stronger shield, a faster projectile, a weapon that could defeat the armor protecting against the previous weapon. The history of weapon forging is therefore not simply the history of violence. It is also the history of metallurgy, chemistry, engineering, mining, international trade, manufacturing, and human experimentation. The same ability that allowed humans to understand stone, control fire, extract metals from rock, manipulate carbon, and manufacture steel also produced agricultural tools, buildings, transportation systems, machines, and eventually modern industry. Human beings did not wake up one day knowing how to forge a sword. It took thousands of years of observation, failure, experimentation, and accumulated knowledge. And somewhere between the first sharpened stone and the first forged steel blade, humanity discovered something that would repeatedly reshape civilization. The material from which you build your tools can determine the world you are capable of building.